Hello guys, this is the first video in a new series where I'll be building an 8-bit CPU on breadboards. My audio is probably not that good and the video probably isn't either, but I've only got my smartphone now, so we gotta do with that. So let's just start. This here is the clock module, and well, I think it's pretty obvious what it does. It blinks a light when you need it to, but no, not that one. It turns off in here because I pulled this down. And if I now press the button, the light is now connected to the button. And another thing about the clock is, which I find very important, I can change the frequency. This is about 3 Hz, 6 Hz, 30 Hz, 500 Hz. The camera can't see these, because it's probably recording only in something like 60 frames per second. No, it would be 30 frames per second, otherwise it could actually see it. And, well, 500 Hz, that's even faster. But it can see these fine. The way I've done this is by using a 555 timer here and here. This 555 timer is in what's called an astable mode, which produces pulses constantly, which goes over here. I want a camera focus. Focus. Come on. Well, I've got a capacitor here and here. This is a capacitor from the output to ground to make the signal a bit more stable. And this capacitor, this is a 0.1 microfarad capacitor, and this is 1 microfarad. I've also got a 1K resistor over here, another one over here, 2 10K resistors here, and 2 100K resistors here. What these dip switches do is they're all up now, so they're all off, which means the signal has to travel all the way through here, all the way through all of these resistors. But when I turn this one on, it goes faster, because it now goes through the switch, and it skips this one. So it only has to go through these. Turn yet another one on, and now it only goes through these 3. Turn the last one on, and there is only 1K left. And yeah, I've also got a button here, and well, if I put it in the correct mode and I press it, the light comes on. I have a 10 microfarad capacitor over here and a 100 kilo ohm resistor over here. And this 555 timer here I use it to debounce the output of the button. Because what a button does is when you press it, it doesn't connect immediately. Sometimes it bounces. And you can't use that for a clock because it would look like, oh, 1, 2, 3, 4, 5 times they've pressed this thing. And so we'll iterate 5 times. When really, you've only pressed it once, but the plates that connect bounce. So the 5 for 5 timer circuit over here prevents that. To select between the button and the clock, I have a bunch of transistors set up over here, and this is an AND gate, this is an AND gate, this is a NOT gate, and this, what should I call it? It is a AND gate with one input inverted. That's probably the best explanation. 5 volt travels through here, but only if from the collector to the emitter, but only if the base is grounded. So, and yeah, if I take this resistor and I plug it into 5 volts, the clock pulse won't get through. But if I ground it, it will get through. Which is exactly what we want. And this up here is just hooked up kind of separately, but the output of this AND gate also goes to the input of this transistor over here. These are connected. There is 2 separate transistors for them, but they are connected. Little wire over here. And this wire, when I get to it, is going to be the wire that picks between the regular clock outputs and the button output. And that is right about everything I have to show for now.